This, at first glance, looks like another example of a rational expression we can integrate by using partial fractions. But a big roadblock here to using partial fractions on this problem is the denominator does not factor, and that really can cause issues with trying to integrate using partial fractions. You really need usually to be able to factor um, the denominator in some form. Um, However, that doesn't mean that we cannot find the antiderivative of this rational expression. We can do that by using completing the square, or at least we can attempt to complete the square. So let's try that and see where that leads us. So um, let me rewrite that denominator over here, and let's go through the completing the square process. So I'm going to group together the x squared minus 2x plus minus 2x, right? And then separate from the plus 6. And now let's try to write x squared minus 2x plus 6 as a perfect. I'm sorry, x squared minus 2x as a perfect square, correct? So to do that, I'm going to have to add in this constant term inside the parentheses, and we know what that's going to be, right? We'll take the middle term here, which is minus 2, the x coefficient, which is minus 2, divide that by 2, and square that. So minus 2 divided by 2 is negative 1 squared is going to give us 1. So I'm going to add inside the parentheses here a plus 1. And then to compensate for that, right, I'm going to subtract 1 outside the parentheses, right, so that I haven't changed the expression. And now indeed x squared minus 2x plus 1, right, is going to factor as a perfect square. That's going to factor as x minus 1 squared. And then, of course, 6 minus 1 is 5. And now I'm going to rewrite the 5, right, as a perfect square. I'm going to rewrite the 5, right, as a perfect square. And that's easy to do, right? That's square root of 5 squared. So let's put this into our integrand. So I have x minus 1 squared plus the square root of 5 squared, and that is exactly an expression that we can integrate using arctangent, right? Because it's the sum of two perfect squares. So this is going to integrate as 1 over the square root of 5, right? My constant squared is square root of 5 times the arctangent of x minus 1 over square root of 5, and then, of course, plus the constant. So there is my antiderivative, and I didn't need partial fractions, right, to find this antiderivative.